I get it that you might have not been able to optimize this, right? So today, in today's session, we are going to explore how we can optimize this antenna design. Okay. So, yesterday we left at this point where we had an antenna and we were trying to simulate it and optimize it. So let me in analysis setup, I have a setup one, that is the adaptive frequency of this setup one is 2.5 gigahertz, and it is a single frequency solution. In this, we have added a fast sweep from 2 gigahertz to 3 gigahertz, and we are scaling with number of points. We can say in that. Then we have selected 201 points between these frequency range, and we are saving all the 3D fields in this. So when you are saving the 3D fields, it will increase the size. It will occupy more memory on your hardware. So keep in mind to clear the uh, results that are not required. Now let us click here, right click on this, and go to analyze. Okay, so from analysis, so we find out that our antenna is having this parameter, and the 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 S11 is below minus 10 dB at 2.4 gigahertz, but it is not much. So how we can improvise this? So first of all, let's see what is happening here. Let us delete all other results. Now we have only S11 and Z11, the real and imaginary part of the impedance. So here we can see that the peak of the real part is up about 100 ohms. Okay, and if we directly here add a marker, then we right click, add a x-axis marker, and select here. So here it is, the peak value is 101, and it has a reactance of 16 ohms. Okay, so we need to optimize this. For that, we can measure the impedance by changing the length of this L in, and I don't want to change it to one step at a time. So what we can do a batch processing. In batch processing means let us first check what is the value. This length was given by L in, so the inset length is 4 mm right now. I want to take it up to 10. So one option is that I change it to 5, then 6 and 7, and one by one I simulate the design. Or what we can do, we can go to the simulation tab and select this optimetrics. Okay, in optimetrics we select the parametric variation. So if we click on the parametric, then this window will open, that is used to set up the analysis. Here, when we click on the add button, now we see here the number of variables. So what are the variables we had? All these variables are available here, and this includes the LDM, that is an over post processing variable. So we don't have to change that because that will not affect anything. Now we are interested to change the depth of this microstrip line. So we select the L in. Then here we have a start and stop value, and here we can mention the step size. So there are a lot of options here, like we can do a single value for this variable. We can select a linear step. We can select linear count. So if the step size is not clear, I want to set this L in between 4 to 10, and I want three variations in this. Okay, so when I click add, then this variable will be put here. Now let us click OK. Now it is saying that we are varying this variable L in from 4 to 10 in three steps. And if you click on this tab table, then what will be the values of L in 4 7 and 10 Okay. If we increase the number of counts here, we increase this number of counts, then this will increase. Okay. So you can set according to your requirement, and let us click OK. Now go to below this analysis tab, there is an option that is optometric. So this setup one was created by me earlier, and this setup 2 is that we have just right now created. Okay, this is setup 2, and table we have explored. Now if we click on the general means in this setup, what are the variables, what are their values. Okay, so these are the default values of other parameters. We can override this by changing from here. If we do not select this, revert. Okay. If we do not select it, we will not be able to vary this. Okay, so we that will collect the values, and if we want to override whatever is there in this current position, whatever the variables are there, we want to override that, then we can set up there. Okay, so now we have only varied one parameter. What happens if I vary the width of this slot? So that was taken by W cut. So I select W cut, and its nominal value is 1 mm. By default, it is giving with 50% variation from zero point 0.5 to 1.5. I want to change it from 1 mm to 3 mm in a step of 1 mm. Okay, so we can either give the step size, or we can select the linear count, then click add. Now click OK. So now we have two type of variation. L in will vary from 4 to 10, and W cut will vary from 3 to 1 to 3 in steps of 3. So it has 5 variations, it has 3 variations. Now if you go to the table, you see how many variations are there. For each value of L in, there are 3 value of W cut. Okay, so it is basically making a all the permutations. Whatever values are there, it is making a permutation. So we can see that L in was 5 values of L in are there, and 3 values of W cut are there. So all these three are okay. Then we can add some more values if you want. So here we can add manual entry, and then what we can do, we can export it. So let us save this as uh, by default name, and then go here and click on delete. So now once we have deleted it, now go to table. There is no table. Okay. Now click OK. Click cancel and delete this whole setup. Now there is no parametric setup. Now select optimatics again. Go to parametric from a file. If we click here, it will open a browser, and we can select, and in the file explorer we can select this file that we just saved, and click open. Now if we select this, it will say that there are in the Excel file there were two variations, and these were the values. This was exact same. Okay, so we can input the variations from our files also. So we can create this such kind of file in Microsoft Excel. Right click here and open it in Excel. So you can add more sequence here, more parameters, their values, and whatever combination you like to analyze, you can make it. Okay. So sometimes it is not possible for us that for 8.5 value of L in, we want to check the variation in W cut for only two values. We don't want it. So we can set it here. Okay. Now our set parametric setup is there, but I want to change it. Click OK. So now it says that it is not taken from an table, so it is not it is giving some error. Okay, so when I click edit, then go for linear steps. I want to vary from 4 to 10 in steps of in 2 steps. Okay, so 4, 6, 8, 10. These will be the values. Now I update it. I'll go to table. The updated values are there. So now you see that the W cut has the default value of 1 what happens to the other remaining values? Here we had three values of W cut, but here only one value is there. So when we edit from the table from that we imported from a table Excel, then it will reset all the values to a nominal value. Okay. Now uh, now we can either right click on this and validate this setup, and then after validation we can go and analyze this. Okay, so the parametric variation is started. Now it is saying that it has solved one parameter and solving another one, and there are two remaining solutions after this. So there are total four variations we are studying. So you can see here as the length, depth of that insect feeding is increasing. We are the input impedance matching is increasing, and if we go here, select the real part, go to families, check all the values, and click new. So here we can see for different values of L in, the peak value of the real part of impedance is changing. So according to that, we are getting the variations in the S parameters. Okay. So at this 8 millimeter, we got the maximum matching, and the resonance at 8. Let us set this value to 8. So here we can see that at this is the peak, and this is the your resonance point, and around here we are getting the maximum matching. So you can see at 2.416 gigahertz, the real part of the impedance is 50 ohm, and the imaginary part is 1 ohm. Okay. So because of this reason, we are getting the dip here. At this point, we are getting the impedance matching. So most of us directly see the S parameters, and we see the uh, dip in the S11. So that simply means that our antenna is matching at that point. So sometimes we match this antenna, and if by accident we have not changed properly matched this line transmission line to 50 ohm, then what will happen, as the propagation effects will take place, and we will be getting different results during our measurements. So please be careful when you are designing this kind of trading, and when you are confirming your resonance, please take out this that parameter. Okay. So far, we have created this antenna, and it is giving very good result at this point. Now, if we right click here and sorry, right click on this and modify the report, go to families, and we want to set it to nominal. Then we can go here and select this one only. Or you can set all variables to nominal values and click apply. So this is your result. Now we have explored two options in the simulation: uh, optimatics, parametric, and parametric variations. Uh, in some cases, what we want to analyze how much sensitive is our antenna or parameters with respect to certain parameters. So you can select this optimization. Sorry, uh, you can select this sensitivity analysis. In sensitivity analysis, what we can do, we can include some parameters, and the variation of those, how that parameter is affecting our result, that we can analyze. And optimization, in optimization, we set a particular goal that we should be getting this much frequency range. So if I click here in optimization, it is asking for to select an optimizer. So let's select an multi-objective optimization. Then it is asking us to add some calculations. Okay. So calculation are the cost function with respect to which we want to optimize our result. So when we click on the selection, set calculation, first we are going for S parameters. We want to maximize the bandwidth of our antenna. So we will be selecting S11 in dB. Then uh, we go to calculation range, and here we are seeing that this is the frequency range. Now I want to make my antenna to have a bandwidth from 2.3 gigahertz to 2.5 gigahertz. That I can set here. Okay. If otherwise, what will happen? Suppose we are getting a bandwidth from 2.1 to 2.3 gigahertz. That is more than that is 200 megahertz, but that is not covering our desired band. So we need to select this frequency range very carefully. Then click on Add Calculation, and done. So when we click on Add a calculation, that calculation is there, and this parameter S11 is there. We have this calculation range to that we set. Now, what is the desired value of this? So there are conditions. We can have it equal to, or we can have it set to less than equal to, greater than equal to, or we can have it to minimize. Okay. So let us set it to minimize, or let us set it to less than equal. Now the goal value. What is the goal value? Uh, Goal value is we want this value to be less than minus 10 dB. That is our goal value. Now, similarly, if we add multiple setups, then if we are adding multiple calculations, then we can assign them weights. Okay, these weights will be useful when we have multiple cost functions. Now, this we have set up, but when I click OK, it says no variable is included. So now click OK, and check this. The, that setup was saved, but it gave us an error that there is no variable. So what is variable in this case? if we click here, then we see that there is an empty list here. There is no variable that we want to optimize in general, so anything. So let us cancel this one. Now again go to this SFSS and select all the design properties. Now we see there are all these are variables, but in optimization setup it is saying that there is no variable. So these are the nominal values of these variables. Now click here on the optimization and design of experiment tab. So here what we can do, if we see there is no variable that is included for optimization. So we need to optimize this with the input length and W cut. These two values we can optimize, and we give the range of this, that in this particular range you have to search. Okay. You can set other parameters like the patch width or the line width. Okay. These four parameters we have added. Then click apply, click OK. Now go to the optimization setup again. Now if we go to the variables, then it says L in LP all the. Now this override means that whatever range that we decided earlier, we can override that range. If we do not select here, then we will not be able to modify this. Okay. So reset this, click OK. Now we have one parametric variation, we have one optimization setup, and we have one normal simulation. So we want to run all these in one by one. So what we can do, we can go to simulation, and in nearby validation there is an option that is called analyze all. Okay. So this analyze all, what it will do, it will run all the setups. We can have multiple setups if you are designing a dual band antenna that is operating at 2.4 and 8 gigahertz. So we set up one setup at 2.4 gigahertz, another setup at 8 gigahertz. So we can have multiple setups. So instead of running every setup one by one, we can go and select analyze all. So when we select this analyze all option, first it will be simulating this result. So it is simulating this setup one. Adaptive passing meshing is there. Uh, After this, it completes this simulation. Then it will go for hierarchically. It will follow the order. So it will go for optimization. Then it will go for parametric variation. So now it has started patch optimization analysis, and right now there are no solutions available in this optimization. It is currently solving one problem, one parametric set. Okay, and let us wait. Now it has solved one variation, and it is carrying second variation is there. Now if I right click here and click on this view analysis result, so here we can see in table format these four variables that we included, and it is calculating the cost uh, for these variables, and it is randomly varying in the range that we specified. Okay. So now in here we can see that in first iteration it got around 93, then in second iteration it got around 30, in third iteration the result got worse. So what it will do in next iteration, it will move around this particular point. Okay. Now if we go here, and we have to set the optimizer, and in click on the general tab and option. Sorry, in optimization there is a button that is setup. So in setup we can check what are the parameters here. So in multi-objective optimization, we have number of initial samples. Initially, it will take 100 samples out of the chassis space. Then it will retain 50 samples and perform this ratio operation. Then maximum iteration it will do 20. So that means 20 into 100. It will take around uh, estimated variations are there around 1100 estimated variations are there. So after 1100 variations you will be able to get your results. Okay. Or if we all the in this complete range we got a parameter less than 10, then also it will stop. So let us see how many variations it has done. 8 variations already. Right, click here and check the view results. So now we see that this second variation was the best result so far. And if we click here, right, select this variation, and after selecting this variation, if we click up, it will take some time during running. So now it has applied because it is saying reverse. Okay. So if I close it, I think I might have set the different goal. It is giving making it best. Let us see what are the other variations. Go to the tab, select the worst one, and okay. So in the worst case, we are not getting any dip here. So that was the best one. So what happens for all these 201 points in the sweep? It is selecting the points that are falling in our frequency range, that is 2.32. From this point, from 61 to 200. At 40 frequency samples, it is calculating the difference between the actual as parameter that is obtained and the set value. Then it is determining the variation between the. So let us set right click here. Again, go to analysis. So it has already calculated 14 variations, but somehow it is not displaying here the values. Okay, now it is showing. These are the variations in the profile. 15 variations completed and followed. So what you can do, you can design a shape, and you want to add all the possibilities. And initially, what you can do, if I had set this value to around 9, then I might have got a result sooner. So what we need to do, we can follow a parametric variation for each of the design parameters, and in after performing the parametric variation we might get some basic values, basic closest values of all variables. Then we can set those values and apply the optimization. So if our initial value is closest, then we will be getting the better results and we will be optimizing faster. Right now, the initial values were not okay, so that is why we are getting this result. Okay, so uh, in between the simulation, what you can do, you can click on this play button, and it will ask you to abort or clean stop. There is difference between these two. Abort means stop right now, and whatever results you have previously calculated, keep them. Clean stop means clean all the 19 simulation variation and stop. So let us click on abort. So all the 20 results will be present in our memory. Now if I click here, right click and go to parameters, and so these are this is the value, and if we click here and go to families, you will see that all the variations that were present there, they are available here. So right click here and see the result. Why this table is not? I think there might be some error. So you can select the profile, and you can manually select. You can check the uh, cost here and then select this value. Okay, or for any case you can reset the example. Okay. Then after optimization, there is one more option available in simulation. Optimization, then sensitivity analysis is if you want to check this parameter and check variation of one parameter on how it is affecting our results, that we can do in sensitivity analysis. That takes different algorithm. Then in research methodologies in most of the universities, they teach some method that is called design of experiment. So you can also apply design of experiment here, but we should not. I do not personally uh, prefer this one because in our antenna design we have a lot of parameters. So that will in, just increase the number of samples and test that will take a lot of time to simulate, and from that also we are not able to find any significant results. So either we go for optimization, and you can choose on your own whatever options you want. Then in design parameters, go to HFSS, select the design properties, and in design properties, select this tuning. Okay, so in tuning, what can happen? For example, I want to change, see the variation of L in, and its default value is this, and click apply. Okay, and to delete this one, this one, this one. In tuning, in tuning, what will happen that we will be having a scroll bar that will allow us to tune the parameters, but I think that is not available in this current version. So you can use this to optimize your design. Then one more thing, what you can do to speed up your process, you can select this HPC options. HPC stands for high performance computing, and if you click here, then it selects the number of machines available to you. For example, if in your university you have set up HFSS on 10 machines, and you have enabled this high performance computing, then you can add all those, and then what you can do in that, click on edit. When you click on edit, here is the machine for distributed analysis. Distributed analysis is in our and for example, we want to perform the uh, optimization. So right now we just said, seen that in optimization only one variation was there, So we did not even completed first iteration. In first iteration, there were 100 samples were there. Then it would it would have gone to second iteration, then a third iteration. So depending on your number of cores of your system, so how you find that number of cores, go to task manager, click check for the performance and check for the CPU. So here you will be able to find out your number of cores. So here you see my system has 6 cores and 12 logical processors. So my system can support up to 6 cores, and so select the number of cores to 6. I have one GPU only. So then uh, what will happen? I can use maximum 6 simulation one at a time. So in edit, I have set this number of cores to 6. Uh, let let me set it to 5 because I want to keep one of the core free for other operations. Then let us go here and go to parametric variation. Now first let me reset the values of you see this w got 1 some values we got variations. These variations were made during the optimization, so I reset it. Now click on the result, right click, and here you can see that there are several options. You see here clean up solutions. So when you clean up all the solutions, it will delete all the results, and depending on your size of the variation, it will take some time. Now all the results are cleared. Now click here and there is an update all reports. So click on update all reports. All variations have been eliminated. Now set up a parametric variation, and in parametric variation I am varying L from 4 to 12 in steps of 1, and I am varying W continue from 1 mm to 2 mm in steps of 0.5 mm. Now if we go to table, we see there are 27 variations. Click OK, then click on analyze all. So first let me see if I have set it up. Click on this uh, analysis configuration. Here we can set this number of cores. It is enabled. Okay, high performance computing I have set to enable. Now I am clicking on the analyze all, and simultaneously I am closing everything else. Okay. Now we go to performance and check your memory. So right now I have 32 GB RAM, and out of that 32 GB, I'm only using 11 gigabytes. And right here, here all the boards. Click on analyze all. Insufficient. Okay. So what is it is saying that I don't have sufficient licenses. Okay, only 4 of the 5 requested. So I have maximum 4 in student version. We can simulate maximum 4 simultaneous simulations. So let us set it to 4. Then clear all the message and analyze again. Now initially it is simulating for this particular setup. That was the base setup. Then it will start simulating the parametric variation. So let us wait for a bit. Okay. Now uh, here we can see that it has started solving one parameter is enabled. Okay. My mistake. Currently it is solving one parameter at a time. So let us abort this one. Now go to simulation. Now here we can set number of variations to distribute. So I am setting it to 4. Then click on analyze all. It is asking that you want to use this MPI. So click yes. Now you can see that it is solving 1, 2. Okay. I think there is some error. Okay. Right. It is solving 3 runs, 2 runs. 1. Okay, so in this HPC, we can distribute our parametric variations, and I'm getting it is only solving one because initially it started 4 variations simultaneously, but it got stopped due to license error. So there might be something that the simulation was terminated due to license error. Maximum license number of demo user already reached. Okay. So these are the some limitations associated with the student version. If you are you have full academic version or a professional version, then you might not see these errors. Okay. So now let us clear this. So far we have discussed about how you can set parametric variations and optimization and other things. Okay. Now before proceeding to MIMO antenna, there were some queries by you yesterday. So, so some of you wanted to know about curvatures and other. We do not have software in the system. We will. Okay. So some of you had a query regarding the uh, curvatures uh, of this. So today, let us discuss that first. Let me delete all this. So now, what you can go to draw menu and go to desktop, click on this SFSS, so it will insert a new design. Then go to draw menu. Here we have some primitive shapes like box, this box shape, can cone. So let us click on the cone. Okay. This kind of basic shapes we can draw. We can draw a cylinder and so on. Now what we need to do if we have a idea to create a face, uh, for example, I don't want this solid cone and I want only a part of this one. Okay, so what we can do, we can move these items to create a shape that we want for, and let us delete this one, delete this one, and I kept this pair, set it to 0, 0, 0. Is 3 points. mm, and radius of 5. Okay. Now let us create a cube. This cube we have created, and we will be performing the subtraction intersection operation as we discussed yesterday. So now we are able to see only this kind of shape. Okay. Now click F, that is a shortkey for selecting a face. Then in this object, if we rotate, we have several faces. So let us select this face, this circular face. We want to select. Click F, and you will be able to select this face only. Now once we have selected this face, what we can do, right click here and go to edit. In edit, go to surface and create an object from this surface. So when I click select any face and created an object, so it will create a sheet. So the sheet we can see, and now we can delete this shape. Now this is a curved surface. What we can do, sheet means a two-dimensional object, or that does not have any thickness. So now we select this sheet and we select this line. Sorry, here these are that move along a vector. So if I click here, so it will move this sheet and it has created an unclassified object. Okay. I will demo that later. So in this sheet, what we can do, from here we can select this operation that is called thicken sheet, and we can increase the thickness of this by, let's say, 1 mm, and like. So now you see, uh, earlier it was a sheet and now it is a solid object. So now we have created a solid object, curved solid object like this. And okay, this is one option. Now let me delete everything. Reset to isometric. Click on this cube. Now we have created a cube. Now select its top face. Now I have selected this face, and let us click on this button. It says move along a normal. That means, so it move by one distance this object. So you see here we have increased the height of this one. So let us select this face, right click, go to edit, go to surface, edit surface, and detach the surface. So now this face is detached from the original box. Now we click on this, move along the surface and make it see. So this face is moved along this normal line. Select this one again, right click, move along a face vector. Move this vector. So this movement we can do. Now select this face and sorry, this is a sheet. Select this one, click on the thickness sheet. Now increase it to 20. This has increased the thickness of this one. Now you see, if we go to front view and 1, so only in positive Z direction we are the variation is only in positive Z direction. If I double click on the property and select this move in both sides, then after varying, let us make it 10. So now it is increasing the size in both the axis, positive and negative axis. Okay, that was there. Now let us we have a sheet here. So delete this object, select all, fit all, delete this box one. Now let us create a cylinder and go to isometric view. This is our cylinder, and this cylinder is starting from z equal to 0. Now let us create a sheet. This is the sheet, and this sheet is placed in xy direction only. So I check in properties we can set this to y. Now select both the objects and see here it says wrap sheet. So I click on this wrap. The thing was it should be touching the surface. So let us go to the top, and the cylinder has a radius of 2 mm, and the sheet should start from 0 to 0. In x-axis I want to extend it to 5 mm. In z-axis I want it to extend to 2 mm. So now if I click like this and I want to see all, so we see that both this sheet is touching the surface. Also make it to in x-axis set it to minus 2.5, so it is symmetric. Now let us try to wrap it again. C2 body cannot be created the part because invalid parameter. Okay, so there are it is possible in SFC that we can wrap these things, but I think there is some. I will check it out and tell you later. So one more thing is, let's delete this one. Now we have this one, and these are the tools that you can use to draw two-dimensional objects like a sheet or rectangle or circular plate. Okay, so now we have drawn an ellipse. Now what we can do, we can select this ellipse and we can sweep this ellipse around any axis. Okay, so what does that mean? So first I select this ellipse and that was a sheet. The variation is in z direction. No, I don't want it. But in y, no. Let us move it to x axis. Okay. So this is the sheet. Now select this sheet and go to this sweep around it. In sweep around, let us set it and click OK. So you can see that that sheet has been rotated around z axis in 360 degrees. So again, check these properties. We want to check move it in y direction or keep it there and set it to 90 degrees. So it will again create an object, a 3D object, but now that sweep is like this. So we have created a 5 basically. So if I click on front view, the right view, so this has created a 5. Let us go to the top view and see if we are able to identify. The ellipse thickness was there, measure radius, keep it 1, and click on. So you can see that sheet has been rotated like, okay. So that is revolving around this axis, and how much it is rotating? It is rotating according to our desired sweep area. So if we give it 360 degree, then it will make a complete circle. If we give it partial angles, then it will rotate accordingly. Okay, this was there. Then let us go to isometric view again, and this time let us move. Now use this. Now we have a single sheet because I have deleted that operation. Now in this sheet, what we can do, we also define a one lines or edges we can also create using this section. This is the three-dimensional section, this is two-dimensional, and this one is one dimension. So in one dimension, select this uh, line. So I'm creating a sinusoidal variation. Okay, and whenever you are double click, when you first select this object and click, it will start counting. Then you just click and it will add new points. Now when you want to finish, you have to click the do double click. Okay, now uh, go to this sheet, and the starting point, it should be 0 0 0. Okay, so this sheet, this is starting from here. Now uh, let- delete this cylinder because we are not interested in this one, and we delete it, this one also. Now create an object. Okay, right now I have created a 3D object. We could have a two-dimensional object also. So select this object and this line. Okay, then we go for, okay, which sheets only we can do. So select, create a sheet like this, and we have placed our curvature here. So I'm going to make it in y direction. Now select both this sheet and this line, and now you will be able to see this sweep along path. It was sweep around axis. Now this is the path along which we want to, this, this is the path along which we want to sweep this object. So click on this. Angle of twist we don't want any, and so now we have created this. Okay. So this is how you can define a path and sweep the two-dimensional sheets or one-dimensional sheets alongside. So for example, let us copy this, and this is the same path. I will mirror it like this. So, so it should touch this the starting point of our path. So I will set it to 0 and 0. Now we have a straight line, and if we sweep this straight line along this curvature, what will happen? Okay, I think I have selected the different order. there is some error. Oh, I've created multiple points. I should have created only one. So let me delete this. Right click, delete the endpoint. Now this is the sheet. So now hopefully it will revolve around. With the straight lines it is okay, but with this curved line it is giving some error. Okay. So with curvature there is problem, and what happens, why this kind of errors happen is because sometimes when we are for example, I am creating like this. That is the problem. So if I click here, this is the shape that I have created. Now I'm double clicking here. So you see this object is still present here. Okay. Now instead of this, I just start from here, select this point. Now select this point. So you see there is an intersection. Now I want to make a shape of this, then double click. It will not allow it. So during that, when we were trying to select other line and this one, so there might be some position where we were crossing. So in crossing, we are not able to create objects. So otherwise, you can see, uh, we delete all this, and this is a sheet, and this is a. Okay. Now I want this sheet and path to wrap around. There is no error because the same thing was there. Now in lines, this is the sheet. Okay, so this one, how it becomes a sheet, when you select this line, you are drawing this sheet shape, and if the starting and ending points are same and you close it, then it will create that line, and along with that it will create an option that calls cover lines. So that close changes this lines to sheets. So let me delete this one, and let me delete this one also. Now I am only creating a very small section so that it does not give any error. Now select this to create an object with sheet very beautifully. Now if I select this sheet and this line, go to this again. Okay. So sometimes you have to check if the object is correct there. And now if I select this sheet, place it here, delete this one, and let us try this with the straight lines. This is a straight line. Now again I am placing a straight line here. Select both the lines and go to this one. So here you can see that we have successfully created a sheet here. So with multiple with two lines, we can sweep them and create objects, or we can sweep a sheet along a line and create a 3D object. Okay. So these are the. I hope you got something out of this. Wrapping of antenna cylinder. Okay. So uh, wrapping of antenna, in that case, what you need to do, uh, you need to create an object and go to its top view and delete everything else. And set it to 0, 0. Okay, now we have created a cylinder here. Okay, on this cylinder, we select how much part we you to have some understanding about multiple ports. So for multiple ports, what we need to do, I just delete everything. And one more thing that from one design you can select some particular objects like I'm doing. I'm selecting this region and this page and the substrate. Sorry, I will not select this page and I am selecting this waveport. Okay, and go here directly paste it. So now all my objects are directly here. So copy paste is very good here. You can copy any design from any file to any file. Okay. So if we see here, we have a ground plane, we have a substrate, and we have a region. So now I create a copy of this ground plane, and I will move this ground plane upside like this, and I give it value 0 p plus h, 0 p plus h. So t is the height of thickness of the copper sheet, and h sub is the thickness of uh, our h sub is the sorry, h is the thickness of the substrate. Okay? So both this, and now I adjust this. So I want to extend it to minus WC to plus WC, and WC is 2.9 mm. So now we have a simple microstrip transmission line. This is ground substrate and this is your transmission line. Now again go to here and select this this rectangle I select, place it here. Okay. So this is the waveport sheet that we earlier designed there. Now I duplicate it and place it on LG. Click apply. So this sheet is available at both the points and it is starting from 0 and extending according to the formula that I described yesterday. So now I right click here, go to excitations, go to port and ports. Okay, so this is a terminal solution. You have to go to HFSS solution type and select it to model solution. Now right click, excitation port, we assign it port 1. Before that, go to the right to in the front view. Okay, so in front view sheet, select the sheet, right click, assign excitation port, wave port. Now you need to draw the integration line that will start from ground and extend up to microstrip transmission line. Again, so right now we were in the front, now go to back. Again, select the next port, right click and give it assignment port, wave port. Okay, it is saying that we have too many, 4 ports. Okay, let's go here. We have already 3 ports, so let us delete all the ports. Now go to right front. Here in front we have rectangle 1. Uh, Assign it some boundary ports, wave port, integration line. Then click here, go to backside, select this, right click, excitation port, wave port, go to integration line. So now we have this. If we check the region, Earlier, the region was starting from 0. So now we have put a port in positive y direction also. So keep it 0 here also. Click OK. Then create a setup. Auto setup I am using. Okay, sorry, cancel. That will take time. So go to advanced. Select a single frequency 5 gigahertz. Click OK and select the sweep 2.5 to 7. OK. So now I click on analyze all because I only have single setup here. ANSYS simulation of machine unable to locate or your local machine. Okay. So I think this might be given like I disable this one. Okay, so there is some license issue, so I will just restart my system. So in this, we have created an transmission line. Now we move to analyze this one. Insufficient. Okay. So now the simulation is running, and while the simulation is running, let us create some report. Create a model solution report, and when you will select this, now you are able to see four S parameters instead of one because there are two ports. So we have S11, S22, S12, and S22. So as this structure is symmetric, we are only selecting these two. So here what you can see in this simulation, the S21 is 0 and S11 is below 30 dB. So what is the meaning of S11 and S21 here? The S11 represents return loss, how much power fed to port 1 is being reflected back. So if it is minus 30 dB, that means uh, out of 1000 watts, only 1 watt power is being returned. That is a minus 30 dB means 1000 portion of the input power is being returned. That is perfectly matched. Then S21 that represents if we give 1 watt power at input port 1 and how much power is being received at S21. So it is not basically power, it is the ratio of electric field E or H fields. So that is the reflection and transmission coefficient. So the S11 represents reflection coefficient. That means how much power will be returned back to the sender, and S21 means transmission coefficient. That means how much power will be sent to the second user from user one. So if it is 0 dB, that means max all power is being transferred, but it has very small variations. So if we click a marker here, So that it is representing minus 0.6 volt, and this one is representing minus 1 dB. So at these two frequency points, we have a loss of some power because 100% power is not being transferred. Some power is being leaked, or due to impedance matching, it is not there. Okay. So this concept is used in your MIMO antenna. So how we can convert a simple patch antenna into a MIMO antenna? Let us create a copy of this complete file. Go to project, right click on project and paste it. So now this one is my a new file. I am renaming it to MIMO and select this one. So in order to create this with MIMO, what we need, let me show you with for example, we have a substrate here, and now again, on this substrate, in this portion, we have an antenna, and we want to add one more antenna on the same surface. We can place it here, we can place it here, or we can place them like this. So all this geometric variation depends on your device type. If your device has sufficient space, then you can separate them uh, far away, or you can make them anywhere. Okay. So based on your device shape and the space allocated to you, for that in this our device has our mobile device has 150 length and 60 width, then you can select a particular portion. So the dimension of that portion will be given to you, and you will be asked to fit your MIMO antennas in that dimension. So for example, this is the whole range that was given to you. In this, you had to put antenna of this size here, and we will be adding some feed here. So I'm adding one feed here and one feed here. Okay. So this kind of MIMO we are going to discuss. So first of all, what we need to do, what we can see the substrate. This is the reason. Let us delete this. Now zoom in. So the substrate is substrate length is not much. So what we can do, we can increase the substrate length, and that is why we created it as a variable. So let us increase the width to 70 or let us set it to 60 That is the standard size for mobile phones right now, and length to 150 Okay. Now one of the antenna we have put here. Now I select patch and paste. So one copy of this is created. Now I need to make it a mirror. I will mirror it along this direction. Okay. So this is the mirror. Now whether it is going exact or not, so select this one, and in x-axis we are giving 0 because we are the normal position is y, so only we are interested in y only. So we want to make a mirror along lg by 2 so that it perfectly matches. Okay. So now you see, otherwise let me show you again. This is patch 1. I select this mirror from here to here. So at that point, that the mirror was placed at that point. So that is why we select this one and go here 0 LG by 2. Click. Okay. Again, we need to make a copy of this wave port and shift it to mirror it. So you see, if your mirror is inclined, then your object is also inclined. So we can set that by setting normal to 0, 1, 0 and 0 LG by 2 and 0. Okay. Now click apply and let us see if it has copied the wave ports also. So click on the isometric view, click on port 1. Port 1 is placed here and port 2 is placed here. Okay. So both the ports are also available. Now we click on simulation. There is some error. Let us set this one. And one more error is there. So go to draw and select the orientation front view and fit this one. Now select this object and this line was defined, but somehow it is giving some error. So redefine this one. Define a new line. Start from 0, move to H. Okay, and go to back. Select this one. Okay, this line is invalid, so we define the new line. Okay, now it is defined. Click OK. So go to the isometric view, fit all, and then click validate. Click on analyze all. Okay, I should have disabled this one. So by the way, it is going to calculate this setup on first, then only it is going to give any results. So right now it is solving the setup. Now it has started. We'll just abort it. Now right click on the results, click model reports, S parameter. I told you that this is a symmetric uh, shape, so we are only interested in these two. So right now you see at these points, this red parameter is your S11. So here we see the S11 is 0 dB. 0 dB means 100% of your power is being returned back to the transmitting port. Okay, no, nothing is being transmitted. At this point, if we calculate it, and what is the value? It is showing minus 24 dB. So that means 99% of your power is being transmitted to is not being returned. Only 1% of your power is being returned on the input port, and, and if that power is being transmitted to the output second port or not. So how we can measure that? We can measure that by S21. S21 is representing minus 30 dB, below minus 20 dB. So that means that power that we are transmitting from port 1, that is not being received by port 2. Okay, so uh, uh, this we can also represent as a isolation. So both these antennas have an isolation of 25 dB. The transmission coefficient between these two is minus 25 dB, but the isolation, that is 25 dB. S21 as a transmission coefficient, then we um, uh, assign the sign
So now, because we are getting this good isolation because both the antennas are very far away. Okay, so in practical applications or in your research problem, you will not find this much gap, this much space to separate the antenna elements. So what you need to do, you need to apply some certain uh, isolation enhancement techniques that that we will cover tomorrow. For today, what you can do, you can the antenna that I gave you the task yesterday, you can select that, and you can either position both of them like this. So if you see the electric field distribution here, the current distribution, both the currents, this one is in positive direction, this one is in negative direction, but both the polarization are same. So if you rotate, instead of making a mirror copy, you rotated this antenna by 90-degree, then both the antennas will be in orthogonally polarized. Okay, so that depends on your orientation of the antenna. And it sometimes we do not have sufficient spacing between available for the antenna. So for that we can either apply some neutralization lines or cancellation techniques. So I will give you a demo, yes, tomorrow for that. And in addition to this, we also need to calculate more parameters, not just the insertion loss and isolation. We also need to find out properties like from the that are related to the MIMO radiation patterns. So that we are going to discuss tomorrow. And if you have any more videos, if you have any questions up to the point that we have covered, please ask.
Participants are requested to ask the queries. If they have any query, they can please drop on in the chat box.
सर और एक चीज
Sir, I think there are no queries.
Okay, ma'am. Okay, so tomorrow I will try to cover the MIMO completely with its radiation pattern and all.
Sir, one question.
We got good results, but which parameter to choose for fabrication? Okay, so after uh, optimization, the what you can do in this, go to modeler and click on export. Sorry. So you have to select all the parameters. You have to complete take the design, and you have to create a, what we say, a DXF file. That DXF file will be shared with the fabrication facilities. They will take the printout and create a mask of those files, and then they will fabricate it. Okay, so with lithography, or we can have some 3D printing machines that will create your files, that will create your antenna according to your file. So for a parameter, if you are asking a specific parameter or the variations of parameter, the variation, if you are varying input length, and there is a value that is at, for say, 8.9 mm, that is the optimum value, then you have to select that only specific length on which you are getting the best result, that you have to select, and then you have to export an DXF file. Okay. Okay, so do we have any more queries?
Sir, I think there are no more queries.
Okay, so I think we can uh, call it a day today, and we can start tomorrow.
Yes. Thank you very much, sir. Sir, it was really very
Okay.
useful, especially the Memo one, which is totally compatible with the future requirements. So for sure,
Yes.
participants are learning and the
So
session is very
from
nice.
tomorrow onwards, we will try to cover one topic, MIMO. Then we will go to SIW and array. I
Right.
hope till now the participants have a good understanding of modeling, because they will be requiring this for next sessions. Okay. Okay. Thank you, Venkat. Thank you, Uthe Kumar ji. Okay, so I would suggest that please create at least one antenna that is operating at 3.5 gigahertz. So we can extend that antenna for MIMO as well as array. Okay, and for SIW we will have to select a different frequency range. Okay, Swati. So if there are no query, we can close the session.
Okay, sir. Thank you so much,
Okay.
sir. We will meet tomorrow again, once again.
Okay.
Dear
Okay. Thank you.
participants, tomorrow the session will start from 9 a.m. You are requested to please join by 8:45. Thank you, participants. Thank you very much.